Hello, honors pre-calculus students. Mr. Hazelhorst coming to you live from room A08 today. I hope you guys are having a fantastic day. Today we're going to take some time and talk through the concept of systems of inequalities. We spent most of the beginning of the week talking about systems of equations, and so now we're just going to change things a little bit. We're going to kick out those equal signs, and we're going to bring in some inequality symbols like less than, greater than, less than or equal to, greater than or equal to. All right. Now, as we go through this video today, I just want you to make note if you have some questions when we get done, and that would not be uncommon, I'd really recommend that you read back through pages 508 through 514. Pay special attention to the example problems that have worked and use those as a resource to help guide you if you get stuck on anything in your homework assignment today. And as always, don't hesitate to use the resources of your classmates and ask a fellow classmate a question to help you out as well. All right, well, let's get rolling today. The first thing that we need to do is we need to remind you of some things about just graphing inequalities, period. All right, now you've done this before in Algebra 1 and Algebra 2, and just some important things that we need to remember. As we graph these, the type of line that we utilize is going to depend on our inequality symbol. So if we just have a less than or a greater than symbol, we're going to use a dashed line because the line of the equation itself would not actually be a part of our solution set. So we want to represent that with a dashed line. If we have a less than or equal to or a greater than or equal to, that would mean that the line itself is a part of our solution. So we go ahead and represent that with a solid line. And then you're going to need to do some shading. And you're going to see today we're going to utilize what's known as a test point to help us determine the correct area that we should shade. All right? So with that said here, as we talk about systems of inequalities, we're going to take, just like we've done with systems of equations, we're going to take multiple inequalities, put them together, and we're trying to find the solution set that satisfies both, or if we have more than two inequalities, both of our inequalities or all of our inequalities. And again, there'll be multiple points here we'll shade as we go through that. All right. So let's go through a few terms that I need you to be aware of. All right. We're going to utilize the diagrams off at the side to help us with this. Okay. So the first term that we need to be aware of is what's known as vertices. All right. And vertices are just simply the points of intersection of our solution region. So if you look at diagram A over here, you can see this yellow region is representing our solution region. And we have 4 vertice points that bound that solution region. Now we have an intersection point up here, but notice that this intersection point is not a part of our shaded solution region, so therefore it's not technically a vertex. All right, so again, we just have 4 vertices in this problem. All right. The bounded solution is the solution set that's defined by all sides of the inequality. All right, so in this problem, we have this bounded solution, right? All sides of the solution set have a boundary region on them. It's clearly defined, right? So it's everything that's below this line, technically below this line, and above this line. But that's our solution set, all right? Now, we can also have what are known as unbounded solutions. And that's when not all of our sides are necessarily defined by an inequality in the system. If we take a look at diagram B here, you can see that we have a quadratic equation, we have a parabola, and we have a line, all right? Those two graphs are intersecting at 2 points, right? So we would just have 2 vertices in this problem, and then the shaded region would be unbounded. There's nothing defining the top. Now, this solution set ends up here, but that's just because our graph comes to an end. If we were to extend this even further, this solution set would keep rising all the way to positive infinity. So there's no bound on the solution set of this system of inequalities. All right? And the last term that we need to cover is, well, what about no solution? All right, well, no solution would occur if we have 2 inequalities that do not share a common solution region. And that's what we see here in diagram C. Right, we have 2 parallel lines, so there are no vertices involved in this problem at all because there's no intersection points that are bounding the solution set. and there's no solution set, so there's nothing to bound it anyway. We can see this line is shaded below, this line is shaded above. They share no common solutions, therefore that would be a no solution problem. Okay? All right, let's just jump into a couple of examples here real quick, and we'll show you how this works, and I think you'll find it to be pretty simple. All right? So here's our example problem to begin with. Okay? We've got two inequalities. We have x squared minus y is less than or equal to 1, and x minus y is greater than negative 2. All right. So let me get to my smart board here. So as we're going to walk through this problem, the first thing that we need to do is we need to graph this set of inequalities. Now, to help me do that, I'm first going to set things kind of in standard form here. So I'm going to rewrite these inequalities a little bit. So in my top inequality, I'm going to go ahead and subtract or add y to both sides and subtract the 1. So I end up with x squared minus 1 is less than or equal to y. And in my bottom inequality, I'm going to do the same thing. I'm going to move y to the other side, move the 2 over, so I get x plus 2 is greater than y. All right, so now we're ready to do some graphing, and we want to try and be somewhat accurate with our graphing here. I don't expect us to be exact, but like take this parabola, for example. We know the basic shape of that. We know this parabola is being shifted down 1 unit. So I'm going to shift it down 1. And then just to help me kind of graph it somewhat accurately, just a couple of points to utilize. I can go over 1 and up 1 in both directions. And then I can go over 2 and up 4 in both directions. And that helps give me the basic shape of this parabola. So I can go ahead and sketch that in. Now, as I sketch this in, before I draw this line, I need to make note. What's my inequality symbol here? Right? Well, I have a less than or equal to. So because it's the or equal to, I get to draw this with a solid line, meaning that if I have a solution here, anything that's on this parabola in the solution set would be considered a solution because, again, of a solid line. All right? So now let's go ahead and graph our second inequality. So we have x plus 2 is greater than y. So we're going to go ahead. If we were to graph this, we've got a y-intercept at a positive 2. And then our slope is positive 1. So we'll go up 1 over 1, down 1 over 1 a couple times. Now, as I go to draw in this line, again, I need to make note of my inequality symbol. It's just a greater than. There's no or equal to. And so that means that I need to draw this in with a dashed line. All right. Now, if I were to extend this all the way across. Now, if I take a look at this inequality, we have now taken the coordinate plane. We have now divided this coordinate plane up into 6 or 5 different solution areas, right? We have this region over here. We have a region here, here. All of this that would be outside or below both of them, and then we have this solution set in here, okay? Now, if I take a look at my inequality symbol, I can get a little bit of an idea of where that solution set should be. So if I take a look at my first inequality, again, that says I should be, my y value, which is represented by the equation, should be, we should be greater or less than that, right? And then y, we're below that line. So I want to test the solution region just to play it safe. The easiest one for me to test, I'm just going to go straight to 0, 0. I'm going to test that out first. And so if I plug in 0, 0 into both of my inequalities, right? So if I plug 0, 0 in for x and y into my first one, I end up with a negative 1 is less than or equal to 0. Is that true? Yes, it is, right? So I know that I'm inside my parabola here somewhere, okay, because that point satisfied that region. But we need to make sure that it works with my second inequality as well. So if I plug 0, 0 in here, I end up with 2 is greater than 0. Well, again, that is also true. So this checks out, that test point of 0, 0 checks out for both inequalities. So this region, which contains a point 0, 0, would be my solution set. And remember, it includes any points that are here on this parabola as well, because that was a less than or equal to symbol. All right? So there's an example of solving a system of inequalities. The other thing that you're going to see today on your homework assignment are some good old story problems. All right? So let's take some time and walk through this one. And we'll kind of give you some tips that we need to pay attention to. Now, there's a lot of numbers in this problem, a lot of information being thrown at you, but as I work a system of inequalities story problem, the first thing that I like to do is I like to go straight to the end. All right, let's figure out what in the heck we're even trying to figure out here in this problem. And then we can use that information to kind of help guide how we set up what we need to within this problem. All right, so if I go to the end, the very last sentence says, set up a system of inequalities that describes how many cups of each dietary drink should be consumed each day to meet or exceed, that's going to be an important phrase, the minimum daily requirements for calories and vitamins. All right? So if I go back to the question is ultimately how many cups of each drink. So now I'm going to go back, and if I just look through, right, it's talking about two different kinds of drinks. We have drink X and we have drink Y. All right, so let's define those variables first. So we're going to let the variable X represent the cups of drink X. And we're going to let Y represent the cups of drink Y. All right? So now we need to go through and we need to write some inequalities that would describe all the information that we're being given here. And if I go back again to the question, it says we want to meet the minimum daily requirements for calories and vitamins. So let's start out with calories here. All right? So if I go to calories, it tells me that I need to provide 300 calories. And if I keep reading through, it tells me that drink X provides 60 calories. And if I keep going through, it tells me that drink Y provides 60 calories as well. All right, so using that information, I can write the inequality that 60 times X, since there's 60 calories per cup of drink X, plus 60 times Y, all right? Now that has to, we want to meet or exceed it. So that needs to be greater than or equal to 300 calories, which is what we're shooting for in this problem. That's our minimum daily requirement, okay? Now they also talk about calories here, right? Or excuse me, not calories, but vitamins. So if we go back to our beginning here, right, we talk about vitamin A. So let's find all the information about vitamin A. So we will need to make sure that we provide, at a minimum, 36 units of vitamin A. They tell me that drink X provides 12 units of vitamin A. And if I go to drink Y, that provides 6 units of vitamin A. So now I can write the equation 12X plus 6Y. It's got to be greater than or equal to 36, right, using all that information, okay? So now we also mentioned vitamin C here, so let's find all the information about vitamin C. So vitamin C needs a minimum of 90 daily units, all right? And if I look at drink X, it has 10, and drink Y has 30, so we can write that information in the equality as well. So we're going to have here, again, 10X plus 30Y. It's got to be greater than or equal to 90. All right? Now, that's all the information that we can take from the problem, but common sense has to kick in here because there's two other inequalities that we need to include in this problem. All right? And what we need to recognize is that it would be impossible to have a negative number of cups that we could drink, right? They can't take cups out of our body, so we can't have a negative amount of cups. And so we also need to include the inequality that X needs to be greater than or equal to 0, and Y needs to be greater than or equal to 0. All right? And so now we're ready to go ahead and graph the solution region in this problem. Okay? I'm going to use a blue pen for all of the inequalities, and we'll kind of talk through the easy way to draw these. Oh, let's go red. That'll show up, I think, the best. All right. So let's start out with x has got to be greater than or equal to 0. So that means our x-axis is a bound, and we need to be above that. It's got to be greater than or equal to that. Right? Notice that all these inequality symbols are greater than or equal to. So we're going to be above every single line. All right? We need to be y is greater than or equal to 0. So our y-axis is also serving as a boundary. All right? So we need to be somewhere in the first quadrant in this inequality solution set. Right now, when I go to graph these inequalities, since all of them are written in standard form, I think the easiest way for us to graph these would just be to use x and y intercepts. All right? So let's start out with our first inequality in blue here. So if I plug 0 in for y to get the x-intercept, right? Well, 300 divided by 60 is 5. So here's my x-intercept. Let's do the same thing with y. If I plug 0 in for x, the y-intercept would also be at 5. And so I can graph this line just using the x and y-intercept. Pretend it's straight. All right, let's go to the equation in red. So again, let's just use the x and y-intercept. So start out with the x-intercept again. If I plug 0 in for y, I'm going to get x is 3. And if I plug 0 in for x, I'm going to get that y is 6. All right? And so we're essentially going down 2 over 1 to get to those points. So I'm going to draw in some extra points just to help me draw those lines. Again, they're all solid lines because all of our inequality symbols are greater than or equal to. Our last inequality written in black up here. So again, let's use those intercepts to help graph this. So I'm going to plug 0 in for y. So that tells me that x is 9. And then I'm going to plug 0 in for x. So y is 3. So we're going down 1 over 3. And that'll help me sketch that inequality. All right? And so now we can shade this solution region. All right, again, everything's got to be contained in the first quadrant. All of our inequality symbols are greater than or equal to, so we have to be above all these lines. So all of this would be our solution set. We would have an unbounded solution here. We would have, let's count up our vertices. We would have 4 vertices, 1, 2, 3, and 4. Right? All of those are points that are intersecting inequalities and bounding our solution region. Right? So if we wanted to meet the minimum daily requirements here, we could drink 6 cups of drink Y and nothing of drink X. We could drink 1 cup of drink X and 4 cups of drink Y. We could drink 3 of X and 2 of Y, or we could drink 9 cups of drink X and none of drink Y. All right? So that's an example of a story problem. Hopefully that helped. Again, I'd recommend in a problem, underline, make notes. Did I get everything that I need? And sketch that out as you go. If you need some graph paper for your homework assignment today, as you do some graphing of these inequalities, there is some located on the front table in my classroom, and you're welcome to utilize that. It can be helpful, especially as we're trying to find those vertice points and doing some graphing. All right, well, that brings us to the end of today's lesson. Here's your homework assignment. Again, if you have any questions, refer back to this section in your textbook. Use your classmates as help. And I hope you guys have a great day. I'll see you soon.